This is problem number 3 for assessment number 8. It asks us to evaluate the integral. And you'll notice this integral is an indefinite integral. It doesn't have any parameters here or any endpoints for us to plug in. So when we do this integral, we're going to end up with plus c. It's something to keep in mind that we'll have to write plus c at the end of our integration. Now, in the bottom, you'll notice that we have root x, and then we also have another function that's to the 6th power. This automatically tells you you're going to probably have to use a u substitution here. So I'm going to do a u substitution for this inside function here because it's got the 6th power, which causes us an issue. So we're going to say u equals 6 plus 5 root x. And then I'm going to quickly write this so that I can do my derivative and say that 6 plus 5 x to the 1/2. Now when I do du over dx, the derivative of this, I know the derivative of 6 is 0. It cancels out. And the derivative here will give us 5 times, when I bring the half to the front, so 5 times a half, then I subtract, so I have x to the negative half. I subtract 1 from the power there. So I brought the power to the front, 5 times a half, and then I have x to the negative 1/2 because I subtract 1 from that power. That's how we take the derivative. Let's go ahead and rearrange this a little bit. So I have du over dx, and that would equal 5 halves. And if I do x to the negative 1/2, that's times 1 over x to the 1/2. And then I can say that du over dx is equal to 5 over 2 root x. Okay, I need to solve this for dx. So I'm going to go ahead and multiply dx across. So let's just cross multiply. We'll multiply the dx across and multiply the 2 root x over. So we get 2 root x du equals 5 dx. Next step, we're going to divide by 5, and we get 2 root x du over 5 equals dx. Now we can actually go ahead and take this and substitute it in for dx there. So we're going to take this, put it in for dx there. That was the whole goal there with our u substitution. So we're going to say equals root, and I'm going to say 5 over root x. I substituted in a u here, so that's u to the 6th, and then I replaced dx with times 2 root x du over 5. Now you'll notice that we'll end up with, if I go ahead and, before I integrate, multiply this in, I'll get 10 root x on top du over 5 root x u to the 6th. So I can simplify that. That's 2, and the root x's cancel, so I get 2 over u to the 6th du. When we simplify that down, I'm doing the integral of that. And this is with respect to u. So when I do the integration here, remember I can bring this up. So before I do it, I'm going to say 2 u to the negative 6 du. And then I can write across here and I'll go, the integral of this would be 2 u, when I add 1 to this, I get negative 5 over negative 5 plus c. When I go to plug these back in, first off, I'm going to say that this u, the negative 5, goes to the bottom, so I get, I can write this as 2 over negative 5 u to the 5th, which then I can go ahead and bring the u back in, which is 6 plus 5 root x, and I can say that this is 2 over negative 5 6 plus 5 root x to the 5th power plus c. And remember this plus c, this is out to the side, it's not in the denominator, and I should probably write that out here a little bit better, plus c.